This is the video explanation for homework 6, question number 1. And here's question. So in the question, we are given that fxy, the joint density function fxy, have this value, have this equation, and their range is x, absolute value of x smaller than 1, absolute value of y smaller than 1, and 0 or otherwise. So the first part is to find that this constant a, what value of this a makes this a valid joint density function. Well, the joint density function have the same, it is the same, for a valid joint density function, it should be the same as the regular joint density, regular valid density function, which is that the integration of this part should be equal to 0. And so to get that, we instead of the usual just one integration, we have to integrate in for x and then integrate for y and then get the final equation. So here, integrate over x range and then integrate over y's range, put the original equation in here. We get from -1 to +1 is the y's range. Also for x range is the same, and solve this part, we get 1. And for this to hold true, we can do further and take the a in and solve that, get a equal to 4. And for part 1 is finished. For part 2, we are to find out if x, y are uncorrelated. Well, if x, y are uncorrelated, their covariance should be equal to 0, or this part minus this part times well, e of expected value of x, y is should be equal to expected value of x times expected value of y. And we can find the expected value of x, y with well, how we usually find expected value for a density function, which is put x, usually put x here, but we have x, y, so we put an x and the y and do the integration over x and over y. Solve that equation, we get 1/9. And for solving expected value of x, we plug in the same equation, but instead over here, we just have an x here, we don't have a y. But we still do the integration over x and y. Solve this, we get 0. There's no need to solve for EY because we all know that 0 times anything equal to 0. And we know that EX equal to 0. 0 times EY definitely not equal to 1/9. So that's that can give us the conclusion that they are not uncorrelated. In order to find, for question part 3, we are to find if x and y are independent. I believe there are 2 ways to find this out. First is to do the SmartNow test, and we find the density function for x and density function for, well, we find x and then find y and time them, make a multiplication of them and see if that's equal to what we have in here. Well, apparently it's not the same, so they're not independent. There are also another way to check for this. In here, yeah, this rule, x, y are jointly normal and uncorrelated, means x, y are independent. Also, x, y are jointly normal and not uncorrelated, means that they are not independent. And we know that this is uncorrelated, not uncorrelated. And we also know that x, y, given in the question, are joint, they are a valid joint density function and they are normal. So that implies they are not independent. For part 4, we are to find joint density function of x squared and y squared. In this case, we can use this rule given in class. Do this up here. Yeah. 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 We have z equal to the function of xy and w equal to the function of xy. In this case, we have z equal to the function of x squared, w equal to the function of y squared, and we calculate j. And because it's squared, we know that z and w are both smaller than 1, larger than 0, because x and y are smaller than 1, are larger than -1. Yeah, and then they squared, they have this range. We have j from the equation from here. Jxy is like this part, so the value are after the derivation, and we have 2x times 2y minus 0 times 0, we have 4xy, and ji is equal to this value in the representation of z and w, and then we plug everything in this equation. We have this value. This is the value for zw. And finally, yeah, that's the joint density function of x squared and y squared. Finally, we need to prove that x squared and y squared are independent. In this case, we can use the same test. We can calculate the fc or fx squared, this value right here, and we can also calculate fw, which is fy squared, that's right here, and know that their solution are this and this. Multiplying, we get this, which is fcw. So this equation holds, and we can prove that it is independent. And that's everything for this question.